Alright guys, this is your quiz review for Module 2, Sections 1, 2, and 3. So the first thing I'm going to start with is just going over Section 2.1. Alright, when Section 2.1 was introduced to us, all we learned about is graphing systems of equations to find our solution. So that means you would go to Desmos, which is that online graphing calculator, and you would see a coordinate plane. And when you plugged in both of your equations, one of them would draw one line, and then another maybe in a different color. And where you noticed that point of intersection was the solution to your system of equations. So if you're looking at number 1, there's 2 equations here. All you've got to do is go to Desmos and plug those 2 in. It'll make 2 separate lines, and where you see the intersection, that's the solution you write as a coordinate. Equation set, and I write 2, -2. That's my answer. Make sure you write x and y as your coordinate for the system's solution. So here's our next 2 equations. All you've got to do again, go to that original problem and write 2, 1. And that's how you do Section 2.1. Huh, interesting. Anyway, moving on to Section 2.2. So in 2.2, we learned about substitution and we learned about elimination. With substitution, you would literally substitute for a variable something else. So for y, the reason I use substitution with this is because y is all by itself on one side of the equation. So for y, I can literally take this -5x minus 4 and plug it into where y is in the second equation. So I can tell y is being multiplied by 2 in the second equation, so I'm going to multiply this whole thing by 2 when I plug it into that second equation. So I'm going to write 10x plus 2, and instead of writing y, I'm going to write that whole thing, because it's being multiplied by the 2, equals 4. Now, I'm going to distribute, and I end up getting 10x. And then I end up getting minus 10x, because 2 times a -5x is -10x. And then I end up getting minus 8. And then I bring my 4 down, because 2 times a -4 is -8. Lastly, let me just do my algebra stuff. Combine like terms. Well, 10x minus 10x kind of cancels. And then we have -8 equals 4. Well, -8 does not equal 4. So basically, this is an example of what we like to call no solution. If you feel comfortable adding the 8 on both sides, you're welcome to. You'll end up getting 0 equals 12, and that still does not make sense, right? I'm just going to erase that because it's encroaching on number 2 a little bit. All right, next problem. So this one I want to use elimination. So elimination, let's see, I like to make sure my variables are lined up, which they are. X's line up with X's, Y's line up with Y's. It's not perfectly linear, but whatever. So I can see, I can either try to eliminate the X variable, or I can try to eliminate the Y variable. Actually, both are pretty simple. Doesn't matter which one you pick on this one. I'm going to pick the y because I can easily make that a -3y, and that's what I need because this is a positive 3y, and to eliminate, they need to be a negative and a positive, because when you add them together, then they'll cancel, and that's eliminating them. So I'm going to times this entire second equation by a 3. And when I do that, I get 6x, because 3 times 2x is 6x, and 3 times the -y is a -3y, and then equals, well, 3 times the -8 is a -24. So you'll notice, and this is what I've been kind of teaching some kiddos, basically, since I've rewritten the second equation, I'm just going to ignore that second equation now. That was the original, because I have a new one. It's still the same thing, just different numbers. And then I'm going to add these 2 equations together, the first one and the new second one. When I do that, I get a -6x plus 6x, which eliminates, and I get 0. And then I get, I'm going to use a different color here, a positive 3y and a negative 3y, which end up actually eliminating 2, and I get a 0, which sucks because 0 plus 0, you guys should know, is 0. And then I get a 24 plus a negative 24, well, that is also 0. So whenever you get 0 equals 0, this is when we call this infinite solutions. Okay, so sometimes we get coordinates as our answers, and sometimes we don't. And that's when we get either no solution or infinite solution. And now on your quiz, you're going to know what to do when you have these issues. That would be no solution, that would be infinite. All right, let's move on to the last one here. All right, this one says use any method of your choice that you want. So I left it up to you guys. My preference would be substitution, again, because this is what y equals, and since y is all by itself over here, all I have to do is plug all of that in for y. So let's do that. Negative x minus 4 equals negative 2 times y, so basically whatever y is, I need to multiply it by that negative 2. So that's half x plus 2, and that's when, once I'm finished plugging it in, I distribute, because I have to multiply that by 2, or the negative 2. So I'm just going to bring my negative x minus 4 down, equals, well, negative 2 times a half is actually negative 1x, and negative 2 times 2 is negative 1. Or no, I'm sorry, negative 2. Wait, no, negative 4. What am I thinking? Oh my goodness. It's been a long day. Okay. So now I've got negative x minus 4 equals negative x minus 4, because honestly, that 1x, I mean, it's here too technically, right? Imaginary 1. So let's see how this works out. Okay, let me get a different color going. I'm gonna add the 4. Oh gosh, what's going on? It's glitching. I'm gonna add the 4. That cancels, so does that. I am going to get negative x equals negative x. When I divide out the negative 1, and I divide out the negative 1, I end up getting x equals x, which is actually similar to 0 equals 0. So this is another infinite solutions. All right, so the last section for this quiz was section 2.3, and that was a lot of word problems that were involving system of equations. So I gave you 2 word problems here. And so all we've got to do is we've got to read through them, derive all that information out of them, set up 2 separate equations that are a system of equations, and then we'll be good to go. I'm going to zoom out a little bit so I can get the whole word problem in. Okay. So here we have an investor buys a total of 360 shares of 2 stocks. The price of 1 stock is $35 per share. The price of the other stock, I don't know why I underlined the price, is $45 per share. The investor spends a total of $15,000. How many shares of each stock did the investor buy? So it looks like one of our equations is going to be just about shares, and one of them is going to be about the amount, like the money. So 2 stocks, if I add, I don't know how much stocks he bought of the first stock, and I don't know how he bought of the second, but in total, he bought 360 shares amongst the both of them. So that's my first equation. Stock 1 is X and stock 2 is Y. I will make the first stock the $35 a share stock. So 35 times that stock is how much that stock is worth. I don't know how many I bought, but I know how much they're worth. Plus the second one, which is the Y, is 45 a share. So 45 times Y, again, I don't know how many of that second share I bought, which is what Y stands for, but they're $45 for every one of those shares. That equals $1,500 or $15,000. And so here are my 2 equations. And so we're trying to figure out how many shares of each stock. So we're basically trying to figure out what is X and what is Y. So we're not just solving for one of the variables, we're solving for both. And I think on a lot of your section 2-3 questions, you were solving for just one of the variables. So honestly, my suggestion with these, especially when you have variables that are by themselves, even though they're on the same side, I would just move one to the other side. So I subtract y on one side, subtract it on the other. Now this new equation is x equals 360 minus y. And the reason I did that is because now substitution is going to be so much easier. If you try to do elimination, you're going to be multiplying by like 35 or 45, and those are going to get you some big numbers. And the bigger numbers, the bigger chance for error. So I would do substitution. So now that I know x equals 360 minus y, I'm going to plug that in for x here. So let me rewrite that equation. 35, and instead of writing x, 35 is multiplied by x, which x is 360 minus y, plus 45y equals, oh no, I ran out of room. Let me scoot it over. Get right off the page. 15,000. All right, so now I have to distribute. So 360 times 30 is 12,600. And then 35 times a negative y is a negative 35y plus the 45y, just bring it down, equals the 15,000. I'm going to combine my like terms. This is a negative 35y plus 45y. Don't forget that negative that's in front of the 35. So basically, if I have 45 minus 35, I get 10y. Bring everything else down. And since it's a positive 10y, I'm going to put a plus. Oops, that should be a 6. Let me erase it. Okay. All right, and then bring that down. Then I just subtract, because this is a like term with the 15,000. 0 minus 0, 0, 0 minus 0, 0, 10. To borrow, oh my gosh, have you guys seen borrowing before? Crazy. 4 minus 2 is 2, and that's it, 2,400. Yes, calculators can do it, but so can I. Anyway, divide out the 10. Whenever I divide by 10, I just take off the last zeros. Basically, our answer is 240 for y. And y, remember, was that second share right here. So that means y equals 240. So he bought 240 shares of that. Now you could solve this easily by just plugging that in right here to figure out x, right? So 360 minus 240. You should get x is 120. And those are your answers. Woohoo! Now that circle kind of took over on the next word problem. Getting ahead of myself. All right, last word problem. And as you guys can tell, these are not infinite or no solutions, so this is how we solve systems of equations and actually get answers. So when you get x's and y's, you can actually write them like a coordinate, or, you know, this is 120 shares and this is 240 shares. Anyway, moving forward. Last one. Calvin mixes candy that sells for $2 a pound with candy that costs $3.60 per pound to make 50 pounds of candy selling for $2.16 a pound. How many pounds of each kind of candy did he use in the mix? Alrighty. First, I need to figure out what I'm solving for. Last time it was shares and money. This time it looks like pounds, which is definitely something I need to solve for. And it looks like we're solving for money again. All right, so my first one is going to be about pounds, so I know this will be candy number 1, you can call it cheaper candy, plus candy number 2, we can call it more expensive candy, because, right, $2.03 equals 50 pounds. when we mix them all together. Check. Then this amount of candy for X is $2, right? So $2 times X plus 360 times Y equals, now this is where a lot of kids get confused, this 216, where does that come in? Well, it's 216 per pound of these two types of candy, but we know how many pounds there are of this new type of candy, 50, right? So it's actually going to be 50 times 216 is going to be our answer. So here's how I'm going to solve. First, I need to know what 50 times 216 is, and that is 108. Okay? So I'm just going to bring everything down. All right, now I can do substitution again, because like I said, these variables are all by themselves. I just need to like move one over, and I usually like moving the y. It's always easier for me. So this new equation becomes x equals 50 minus y, and I know that if x equals 50 minus y, I can just plug this in for x right here. All right, so when I rewrite that, I get $2 times, instead of x, I'm going to plug in that 50 minus y plus $3.60 y equals 108. Going off the paper again. Okay, I need to distribute. So this is kind of, even though it says $2, it's 2 times 50, which is 100. And then 2 times negative y is negative 2y. Because 0.0, these zeros can go on forever, but they really don't count. And then add 360y, which is just 3.6 really, equals 108. Okay, I'm going to combine these like terms. Again, don't forget that negative in front of the 2. It's there. So 3.6 minus y is 1.6, because 3 minus 2 is 1. So this just becomes 1.6y when I combine those like terms. And if I just subtract that 100 from each side, I end up getting 1.6y equals, well, 100, or 108 minus 100 is 8. I'm just going to divide out that 1.6 on each side. I end up getting y equals 5. Okay, just plug that in. I'm going to plug it into our easier one right up here, this original equation. So x plus 5 equals 50 minus 5. X equals 45, doesn't it? So he obviously mixed the cheaper candy more than he mixed the more expensive candy and tried to make a profit. I don't know. I wonder if he did. Anyway, that's all you need to know. If you have any questions, let me know. Otherwise, I think if you've done this review really well, you're ready to take the quiz. Use this review on your quiz. Good luck, guys. Desmos and plugged it in. Here's what I got. You can see up here, those are my two equations. The red one was the first equation, the blue line is the second, and you'll notice that here's that point of intersection, and it is at 2, negative 2. So all I have to do is goes in. Here's what I got. If it'll let me scroll down. All right. So here I have that first and second equation. Over here, that first equation is the green line, the second is the orange line. Here's where it intersects, and that looks to be at 2, 1. And if you zoom in on Desmos, this will actually show a 1 here. So that is the coordinate that I'm going to write as the solution for the system, 2, 1.